In this video, we're going to take a look at problem 24, meaning the penultimate question of the 2025 AMC 12A. So if you aren't familiar, there are only 25 questions on the exam, meaning problem 24 is going to be the hardest or second hardest question. However, we can actually solve this very, very fast. And so I'm going to leave it to you to quickly read through the question, look at the drawing over here, and try to work it out on your own. It won't take you too long. There are a few rabbit holes there where you might get stuck, which can make things very, very ugly for you. So I'll just point those out as we go. Okay, so let's read through it together then. A circle of radius r is surrounded by 12 circles of radius 1. So this is the circle of radius r. These are the other 12. They're all externally tangent to the central circle. So what does that mean? Externally tangent means that they're all touching the circle, the larger circle over here, the central circle. And then sequentially tangent means that they're touching each other like this. Okay, and now we want to find r. The important thing over here is that we want to find r in this form. And this is where things get a little bit tricky. So let me first show you what not to do. Right, a lot of you might say, well, hey, there are 12 circles, right? So we can probably work with angles. Maybe we can connect the centers of these two circles, get something like this, right? And that works well. And then this would be, so this is 1, this is r, this is r, this is 1, this is 1, this is 1. So based on this, it's pretty clear that we've got a triangle like this, right? And maybe this is the path that you had as well, right? Maybe this is what you were thinking of doing, and it makes a lot of sense at first, right? Because you can use this, and now you can apply the law of cosines, and so you'd get something like this. I think this is what you would get. I might be slightly off. Maybe I didn't set it up perfectly here, but you'd get something like this, and then it works out, and you might be able to get an answer, but it'll take you a pretty long time. So don't try this. There's actually a much faster solution, one that you can possibly even do this mentally. If you think of it that way, you can probably do it without even putting pencil to paper. So to see that, I'm going to show you, but before that, please show me your support and give me a subscription. Okay, just click the subscribe button. Only a few seconds of your time, and it'll mean a lot to me, and it'll hopefully help you out as well. You'll be able to see more of these videos. But anyway, let's see what we can do. So you over here, you're very close to the right idea, and this can still work. But what if you just draw another line down here, a bisector? Because of the symmetry everywhere here, when you draw this, you're going to meet right here, meaning that this is going to be a right angle, this is going to be a right angle. You're going to bisect the angle, so this is 15 degrees. You've still got an r plus 1, you've got a 1 over here, and so what you end up with is a triangle just like this. 15 degrees, a right angle over here, 1, r plus 1, and you don't need anything else. That's the beauty of this. You're already done, because the only thing you need to know now is that, hey, this is a right triangle, so I can apply the most basic of, not most basic, but one of the most basic right triangle properties. I can just say that r plus 1 times sine of 15 degrees is equal to 1, right? That's it. And now obviously you want to solve for r, so you can say r plus 1 equals 1 over sine of 15 degrees, not 5 degrees, that would be pretty hard, which means r is equal to 1 over sine. You can also write it the other way, like whatever, what's it called, cosecant, but that's a little ugly to work with if you ask me, so I wouldn't do that. Anyway, now we need to find sine of 15. Here's the issue, right? So one of the formulas for sine of 15 you can get by doing 1 minus cosine of 30 degrees divided by 2. However, this thing over here is actually root 3 over 2. So now you have something like this. And you can see that it's a nested square root. There's a square root here, there's a square root here. So that gets really, really messy. And that's kind of what you'd get when if you did the law of cosines as well. So rather than doing that, how else can you get 15 degrees? Well, that's sine of 45 degrees minus 30 degrees. There are enough ways to do this. You can also say sine of 60 degrees minus 45 degrees. Lots of different ways to get this. But if you do it like this, you're going to get sine of 45 degrees, cosine of 30 degrees, minus, and just be a little bit careful with the signs here and just make sure you remember the formula correctly. Oops. Yeah, like I almost screwed it up here. Anyway, now ignore this. What do we get here? We get root 2 over root 2 times root 3 over 2, root 2 over 2 times root 3 over 2 minus 1/2 times root 2 over 2. Nice. What does this become? This becomes root 6 over 2 over 4. Okay, like you have to be careful. Sorry, I keep messing up. Minus root 2 over 4. If you want to check that you didn't accidentally mess up anywhere here, a nice thing that I like to do is to roughly estimate what the values would be. So this is a little bit more than 2, this is a little bit more than 1. So it would be like 1 over 4. 1 over 4 lies between -1 and 1. It's in the right quadrant. It should be between 0 and 1 because it's in quadrant 1, 15 degrees. So that checks out, looks about right. So that's 1/4 times root 6 minus root 2. Now remember, this isn't what we're looking for. We're looking for 1 over this minus 1. So that would be 1 over 1/4 times root 6 minus root 2 minus 1. So I need you to do this now. I'm going to do it obviously, but I also want you to just pause the video and try it out on your own, because these sorts of computations become very, very useful. And knowing how to do them fast is of course a very important thing as well. So first we can just write this as 4 over root 6 minus root 2 minus 1. And this simplifies to 4 times. This is multiplied by the conjugate to rationalize the denominator. You get root 6 minus root 2 times root 6 plus root 2. So that's 6 minus 2. Beautifully enough, this is just 6 plus root 2 because these cancel out, minus 1. And so it's 6, 2, -1. And we're looking for the sum of them. So that'll just be 7. And I think that should be an option here. Yeah, 7. So C will be the correct answer. Now, I know it took me quite a while to explain this, but remember, it's only been like 6.5 minutes. And in those 6.5 minutes, we've examined the first wrong approach. We've examined another wrong approach where you try to use the half angle property and that sort of stuff. On a real exam, the more practice you do, the more familiar you get with actually being able to solve these and knowing when to use, say, sine of 45 minus 30, or 1 minus cosine of 30 over 2 all to the 1/2. Knowing how to do that stuff, all of that just comes from experience, from pattern recognition and that sort of stuff. Next time you see something with a nested square root, maybe you'll want to use instead the cosine or the sine half angle formula or something like that. Right, so just keep all those things in mind. Hopefully you enjoyed this video. It's a very nice answer over here. I challenge you to maybe consider doing something similar, but not with 12 circles, but instead maybe 6 circles or something like that. So change up the problem slightly. Make sure you still understand it with a more general case. Maybe even it's going to be probably a little bit ugly, but maybe even consider doing it with a much larger with a much more general thing like r different. So just change this, not r, maybe to x different circles, and then see if you can get an answer in terms of x, right? That's how you really get stronger and you really truly understand the problem beyond just whatever I showed you over here. And yeah, that's it. Thank you so much. Bye bye.